As we all know, it's more difficult to get a current source and a voltage source in the real world. Now, I'll show you a current source realized by the ideal op-amp. This is the circuit. It's also a negative feedback circuit with ideal op-amp. So we can still analyze it based on op-amp's two properties, virtual short and virtual open. Firstly, according to the virtual open property, the current I plus through this branch equals 0, and the current I minus through this branch equals 0 too. Secondly, according to the virtual short property, the voltage of this node equals the voltage of this node, which equals U plus and equals UI. Mark it here. Since I minus is 0, the current flowing through load RL equals that through R1. The current through R1 equals UI over R1. It means no matter how the load RL changes, the current through R1 always equals UI over R1. Isn't it a current source property? The current source has a property that its current is constant with the change of the load. As long as UI is determined, no matter how RL varies, I always equals UI over R1. Do you have any question about what I've just said? In the linear region, it's absolutely right that I always equals UI over R1. But if RL has a unsuitable value, then op-amp's output UO may be larger than its saturation voltage. It's impossible for an actual op-amp whose UO is larger than its saturation voltage. Therefore, only based on suitable values of RL and UI, the output of this circuit can have the characteristics of the current source. The last circuit with the ideal op-amp is a negative resistance circuit. Actually, there are some elements showing the characteristic of the negative resistance when it operates in some regions. The voltage decreases with the increase of the current. However, if we want to have a true negative resistance, that is, its UI curve should be a straight line through the origin point with a negative slope. We need to analyze it by specific circuits. Let's analyze this circuit and make sure whether it has a characteristic of the negative resistance. You may have found that this circuit is a little different from those circuits with negative feedback before. In this circuit, the output UO not only feeds back to the inverting input through this branch, but also to the non-inverting input through this branch. Then, as a whole, is it a positive feedback or a negative feedback? We need to discuss the topic of the feedback in depth here. That is, how much does the output feed back to the inverting and the non-inverting input respectively? To analyze the question, UI should be short circuit. Now you can see that the feedback from UO to the non-inverting input through this branch is 0. Because the voltage here is 0 now, the feedback to the inverting input is 1/3 of UO. Therefore, overall, the circuit has a negative feedback. We can still apply the virtual short and virtual open properties to analyze the circuit. Let's analyze it now. Seeing from its input terminals, what is the equivalent input resistance Rin? Firstly, in this circuit, according to the virtual short property of the ideal op-amp, the voltage of this node is UI, and equals 1/3 of UO. Secondly, we will find this current. According to the virtual open property of the ideal op-amp, it equals the current through the 2R resistor. Therefore, I equals UI minus UO over 2R. Substitute the expression of UI and UO here. Finally, we can get that I equals minus 1/3 of UO over R. Okay, now the equivalent input resistance Rin seen from the input terminals equals UI over R. Combine the two equations, thus the equivalent input resistance equals minus R. It's a negative resistance. You should notice that the value of UI and the three resistance should be selected carefully to guarantee the ideal op-amp operating in the linear region, on which the characteristic of the negative resistance is based. Let's see whether the simulation result of the relationship between the voltage and the current of this port agrees with the theoretical analysis. According to the theoretical analysis, seen from the input terminals, the circuit in the dashed box is equivalent to a negative resistance. The negative resistance is minus 5 kilo ohms. With respect to the circuit in the dashed box, we'll calculate the input current due to different input voltage V3. Click Simulate Analysis and Parameter Sweep. V3 is set from minus 10 to 10 volts. The increment is 1 volt, so there's 21 points. The output is minus IV3, which is the input current. Click Simulate. Choose white background. Use cursors to measure. From about minus 5 to positive 5 volts, the circuit in the dashed box can be considered as a negative resistance. The horizontal and vertical axes represent the voltage and the current respectively. The slope is minus 200 microsiemens. The corresponding resistance is minus 5 kilo ohm.